Now we're in chapter 7. So chapter 7, basically here we say, let's use this blue color, called identity, trig identities. So what does a trig identity mean? It means that because of the trigonometric function, basically we're just starting from what is a sine and what is a cosine. And then from here, we even derived tangent. So we did mention about, we just use the Cartesian plane. So now, nowadays, our angle is made such as that. So this is our angle. So you use a triangle to say this is perfectly fine. But then you have a point here, which makes your terminal arm here. So then this one, x and y. So this part is y, this part is x. So therefore, we have this relation. Now from this one, the basic one, now there are a number of the so-called identities could be derived. That means the nature becomes, it's an inherent nature of the trigonometric functions. So in this case, for example, the sine, this theta, multiplied by secant, because secant is just the reverse of the sine. So of course, that equals to 1. Similarly, cosine and secant, this cosecant, cosine and cosecant. Cosine and secant is the reverse of the cosine. Therefore, that's 1. And then, of course, the cotangent is 1 over tangent, and that's still 1. So this is called the reciprocal identities. This one we have encountered before, so this is not something that is to be paid attention to. Now, we also know tangent, as a matter of fact, is sine over cosine. Why? Because tangent is y over x. Now, sine is y over r, cosine is x over r. So the r and r reduce here. They cancel each other. Therefore, you have just y over x, and then that's your tangent. Now, similarly, cotangent is cosine over sine. So, as a matter of fact, now look at this chart here. Now, we have combined what we just mentioned. We have the so-called the fundamental, the basic. Now, sine 7.2, we will get into more identities. It's all derived from one after another. So now this one, we just mentioned about it, that's fine. This one is no worries. Cotangent is 1 over tangent. Tangent is sine over cosine. Cotangent is cosine over sine. And then this one. And this one, and then the 7 and 8. Well, if we prove the 7, then 8 is basically the same thing. So this one is being proven grade 10 when we learn about it. I hope at that time you prove this one. So this one is, so what do I do? So basically we know sine theta is y over r. So now the power, the square, means the square. Now cosine is the same thing. Cosine is x over r. Now if the square, then it's that square. Now we plus them. Plus means this one plus this one. So that means y squared over r squared plus x squared over r squared. So now the denominator is even the same, so we don't even have to worry about it. So then that is to change it. So we just put them together. So then that is r squared. Now on top we have x squared plus y squared. Now think about what this means. This means when we draw the angle as this, so this is our r, and then this is our y, then this is our x. So by Pythagorean theorem, x squared plus y squared equals to r squared. So our top numerator is r squared. Now our denominator is r squared. No wonder this equals to 1. So that's how we prove this identity. Now, if we're talking about this, then let's say, okay, well, tangent square is sine square over cosine square. So that means 1 plus sine square over cosine square. Most of the time, I don't even write this theta. It's just like I just being lazy, so I just do this. So that means I use the denominator, which is cosine square. So then it's just cosine square, and then this goes there. So cosine square plus sine square. Well, cosine square plus sine square equal to 1. Therefore, this is 1 over cosine square. Now, 1 over cosine square is secant square. Then, therefore, this is done too. And this is done, this is done. And then you can just mimic this to prove 1 plus cotangent square equals to cosecant square. So, talking about these rules is one thing. Oh, what's going on with my computer? But here's a strategy. Now, strategy means that basically, if your algebraic ability is high, then trigonometry, they're exactly the same thing. Now, if you can add just a so-called a whole number with a fraction, and you know what is a common denominator, how to do the common denominator, and then becomes that. And then this one here, same thing. So sine over 1, sine over cosine, then the common denominator is cosine. And then so this is sine multiplied by cosine. And then you add them together is this. Now factor also very important in all sorts of algebraic manipulation. Now, first of all, this is so important to realize. This binomial now factor into these two binomials. Now, similarly, this is this. So then this is the same thing, how you factor the in the trigonometric sense. Now, we can also say, okay, well, if it's a secant and the cosecant, and secant, then we just change to both sine cosine. That's fine. So this one is tangent, and then the secant, I'll change to sine cosine. Now the last one, the last but not the least, this is very important. Now this is called the conjugate. So that means we do not want to have any radical in the denominator. So how can we get rid of these? Then that means we multiply the conjugate. And then we can use, this means a plus b multiplied by a minus b. Therefore, it becomes a squared minus b squared. Now, a squared is root of 5 squared, that's 5. B squared is root of 2 squared, and that's 2. So on top, you will multiply by the same thing you multiplied at the bottom, and then it becomes this. So during the exercise, you will see that you would be using this conjugate. When to this level of manipulation, that's pretty the highest level of manipulation you have to try in 7.1. I think this example 1, example 2, all these examples, I'm not going to show it because you simply can follow to read through it to understand how it's being done. So I just want to mention about example 4. Example 4 is determine the restriction. All right. Now tangent is sine over cosine. Cosecant is 1 over sine. And then these two denominators, none of them can be 0. So therefore, your x cannot be pi over 2 because cosine when it's 0 is at that point, this point. Now sine at 0 is this point and this point. So then we have these values that cannot be within this 0 to 2 pi range. Now, I think I don't want the recording to be so long, so I think I'm just going to pick up one question to show in the exercise. So I just want to go down because further we move on. Supposedly it's more difficult. So let me just say question number 9. All right, question number 9. Which one should I do? I want to say that this question I remembered is a bit kind of difficult. Just look at this long thing. And I need all of you to definitely challenge this question instead of me showing what's going on here. So in this case, I might just try this one. Well, this one is also simple too, but let's just give it a try. So it says that we wanted to change all these secant cosecant, I cannot pronounce this thing anymore, all to sine cosine. Sure, why not? So this is 1 over sine square. This is 1 over cosine square. Over, and this is 1 over sine. This is 1 over cosine. You can already see where I'm going. Now, for the numerator, then the denominator becomes sine square multiplied by cosine square. Now the top is cosine square plus sine square. You can see where I'm going. So then the bottom here now is 1 over sine multiplied by cosine. Isn't that beautiful? Because this one equals to 1. Now this 2 denominator, this one cancel with that, this one cancel with that. So in the end, what do we have? We have now 1 over sine and cosine. I thought I could just leave it here, but of course, if you wanted to say, oh, well, I don't like a fraction. Okay, you don't like a fraction? Sure, let's say secant multiplied by, no, cosecant multiplied by secant, or vice versa, doesn't really matter. Well, then that is our answer. Okay, there are quite a lot of interesting questions here. Now, please definitely do diligently this exercise. Thank you for watching.